Hello everyone, my name is Ye. I'm a solution architect from Alibaba Cloud Germany, and today I'm very glad to give you a short introduction about EHPC. So the EHPC is the PaaS level of the software on the HPC topic from Alibaba Cloud. It is built on top of infrastructure from Alibaba Cloud infrastructure like the NAS, Network Attached Storage, OSS, which is our binary storage, and VPC, which is Virtual Private Cloud, and also the ECS, which are our virtual machines. And virtual machines behind the EHPC can be normal virtual machine-based ECS instances, which can also be the bare metal-based systems, which we call Estrigan instances. So on top of this kind of ECS behind the EHPC, it can also be equipped with different software like MPI, like PBS, which is normal software has been used for the HPC topics. And we are also open to work together with customers and partners to bring more software into the HPC ecosystems. Then eventually, what the customer will see when EHPC has been created will be three types of nodes. The first part will be the login nodes, is where the user can be logged into the EHPC. The second part of nodes will be the management nodes, which is where the scheduling software has been running and allocate workload into different compute nodes. The last cluster of nodes will be compute nodes, is where the workload will be executed. So that's the very quick introduction of the HPC, and let's get into handy to see how things can be done quickly in Alibaba Cloud. So first, I've been creating one VPC in Frankfurt region. As you can see, the VPC starting and with CAXW in Frankfurt region. And this one already have one vSwitch, which is subnet in one availability zone of Frankfurt region. Secondly, you also need a NAS, Network Attached Storage, which will be used as for the purpose of the data persistent. You can purchase a NAS service, which is compatible with the NFS protocol, which can also be, you can purchase a NAS which is compatible with SMB. So I will not continue on that part because I have already purchased one NAS compatible with the NFS, which is this one. And if you log into that part, you will find out I have been already creating one mount point, and this one will be utilized when creating on the VPs on HPC. Now I'm coming to the EHPC cluster. First, I'd like to create one cluster on that part. And then since I'm already in the Frankfurt region, I'd like to pick up one availability zone from Frankfurt region, which is the AZA, because my NAS is also attached to AZA. And then from pricing model, as you can see, you can choose from subscription, pay-as-you-go, or spot instance. So I'm going to choose pay-as-you-go for this moment. I will choose a standard deployment mode. I will not give any specification preference on the series of the ECS, although I can choose from all or GPU or network enhancement. So now I'm choosing one core, 1 GB, and with two compute node at default for this HPC. For the management node, I will also creating two nodes with one core and 1 GB of RAM. And for the login node, I will do the same as well. And here I've been choosing the initial scale of the HPC, and we can also set up later on. You will see from later part of the demo, the scale of the EHPC can scale out and in through the workload. So now I'm coming into the advanced configuration. And from this part, you will see I have the HPC here. I'm having a vSwitch has been part of VPC, have been created before. I'm choosing SGHPC for security group. I'm choosing on the NAS instance, which have been showing you later on, earlier time, together with the mount point, which have been shown here. And that will be the network configuration on the HPC. And if you click on advanced configuration part, you can see more information on that. Also with total cost per hour, according to the instance have been chosen, as well as the payment, the pricing model. So if we click on the next step, Now I will be choosing on the public image of the ECS. I will be choosing the normal ones with CentOS, and then I will choose the PBS, which is my favorite job scheduler. And as you can see here, if you unfold the advanced options, there are more information you can be giving here, and also with software versions, which can also be given here. If you're choosing more software to be installed, and you're gonna find out those software will be also ticked up in the list, which list later. And then you could click on the next part. You can give another name here. I would say test HPC. And you will be also requested to give a login user credential. Repeat the credential. That is for the login node credential, not for the job scheduler submitter credential, which you will see later on. And I tick the box to say, yes, I understand. Then we are good to go. Now, after a few minutes, now the HPC cluster has been created. Let's look at the details of the cluster. So first, it's gonna tell me it's a cluster currently in state of running, which is good. It contains 2 management nodes, 2 compute nodes, and 1 logging node. So if I'm coming back into the part, and if I click into the nodes, you're able to see here in the management node, I have 2. And if I'm switching to the logging nodes, so management nodes have only private IP because not being able to be connected from external parties, but with logging nodes, it can be connected by users from the SSH. So now I'm gonna to copy the public IP here. Now, as you can see, now I have been already logged into the login node. So next step, what you do is to first go to the user part. You need to create a user because currently we are not having any user which is able to submit the job from the job scheduler. So here I'm gonna create a user with my name, here one, with the default one, with password. Into this one. So that will be the user will be later on used to submit PBS jobs. So here I'd like to go into the user of myself, and as you can see now I'm in my own part. So now I'm going to create one directly, and here I'd like to simulate creating one PBS job called myjob.pbs. And in this job, it's gonna be very simple task. We'll sleep for, let's say, 3 minutes. Save on that part, and let's get the job there. All right, good to go. So here, as you can see, we have already created a user, and this user is visible from the login part. Let's go into the auto scaling part of the cluster before we submit any jobs. Because as you can see now, we are only having 2 nodes. So if there are a lot of jobs being piping up, there won't be enough capacities to run all jobs in similar time. So I'd like to activate the expand and also shrink capacity. Here, I'd like to change this one into, let's say, 5 minutes. I will keep this one. I will not trying to use a spot instance, and the minimum time of the activate and 2 minutes. I will keep this one. And here, it will also allow you to not shrink everything into 0, so you're able to keep at least 1 or 2 nodes. So if everything is shrink to the end, you still have some nodes are piping up here. So I'm going to choose all the nodes here, so making sure I always have at least 2 nodes in the cluster of my HPC. Click on that part. Click yes, good to go. So we have been set up the auto scaling policy of the HPC. We have all nodes we are already having for this moment. we already have the user has been created. And let's go into a very simple testing for job submission. So for now, of course, we are not having any jobs, not for finished, not for those one has been not yet finished. So I'd like now to submit a job from PBS from the cluster first. So here, quite straightforward. I'm going to ask sub, Q sub, my job, and then this one going to return one identifier of the job. So if I'm trying to refreshing on the page, I will be able to see here I have been creating one job, and the job is currently running because there's at least one node already there. Actually, I have two nodes for this moment. But if I'm trying to submit 5 more jobs, here I can have the handler from 0.schedule to 4.schedule. So if I'm refreshing on the page here, you will see all the jobs has been already identified by the HPC, but there are only 2 jobs are currently running because there are only 2 compute nodes are running in the backend. And for the rest of jobs, they have to be queued up until the system has been triggered and the auto scaling policy got activated, then more nodes can be bring up. Meanwhile, so during time of waiting, I'd like also to create a job, not from the schedule, from the command line, but from console directly. So that is another approach where user can create a job here. So let's say I'd like to create my job from console 1. And I'm not choosing any job template because I haven't created anything yet. I'm using the Ye Huang user at the time with parts where has been created in the cluster. And here I'd like to give, so what eventually will be done, the EHPC console will pick up the user, will pick up the command line, which will identify the location of my job. So if I go to, so basically I haven't put this one in. So if I'm choosing this one here, okay, the job is actually in my current location. So I will pick up this one, giving the location of my job.pbs. That'll be it. Now I'm submitting this one, and you can see the job has been created. Now you can see I have one more job has been created, and this job is no longer having the same identifier when I'm submitting job from the PBS. You can have something differently with different fashion of job ID and with a different owner, because this one no longer from machines, this one's from the from console directly, but eventually it will be the same. Like job can be arriving from PBS, job can also arrive from console. So if I'm coming into the part of job has been finished, nothing has been finished, so there are only 2 jobs in running, and for the rest are queuing. And if I'm going into the nodes for this moment, because there are already enough job has been piping up, so I hope now the auto scaling policy has been already triggered. As you can see, it is. So I have 2 nodes which is running, and there are a couple of more nodes which are running for this moment, and which is in order to satisfy the other queuing jobs in the pipeline. So I'll be pausing the video for a moment to get all the machines being ready. So after a few minutes of the waiting, because there will be some time will be needed to bring up new nodes there, and with all the defined software being installed into the nodes, but eventually when all nodes has been bring up, you can see now we have about 6 nodes which are running. During the time of waiting, I just submit a few more jobs from here to here into the systems, because currently my job only runs for 3 minutes. Now, if I'm jumping into the job nodes here, you will see now because there are more nodes here, and we are having more jobs are running in parallel. So we are having 6 jobs are running in parallel. There's only 1 job has been queued up because now we are having 6 different computation nodes are running already. So that has been shown, like when there are more workloads coming into the pipeline to the HPC can scale in by himself. Now, that also means once all the workload has been finished, and when the auto scaling out policy has been triggered, the nodes will be also shrink back into the original size. So then let's look at the jobs. Now there are still jobs on running. Let's wait for some bit more time until all jobs has been finished, and then we'll be able to see like now all nodes will be also shrink up, and then we only have 2 nodes being left on the systems. All right, now finally, after some time waiting, all the jobs has been already finished. And if you go into the nodes here, because all job has been finished, so if you are going to the nodes and refresh the page here, you will find out there are only 2 compute nodes has been remained, because I configure in auto scaling, I want at least 2 compute nodes for the HPC. For the rest, they all get scaled out. And then if I go back to the job again and looking at the finished jobs, you will find out all jobs has been already finished. And if you click on the job details, you're gonna find out like which class ID that this job has been running upon that part, application which has impact on this, as well as on which compute node has been utilized to finish this job. So that'll be all for everything. And I hope you find this video is useful for you. Thank you for your time for watching, and have a nice day.